Imagine walking into the gym without eating a single thing. No breakfast, no pre-workout shake, no protein bar on the drive over. Just you, your body, and an empty stomach. For most people, that idea triggers immediate resistance. It feels wrong, unsafe, almost irresponsible. You've probably heard it your entire life. You need fuel to train. Food equals energy. No food means weakness. That belief is so deeply ingrained that questioning it feels uncomfortable, like challenging gravity itself. But here's the uncomfortable truth most people never stop to examine. The meal you eat right before your workout is not actually powering that workout. Not in the way you think it is. And once you understand why, the entire conversation around fasted exercise changes. Not just changes slightly, but transforms completely. Most people confuse feeling energized with being fueled, and that confusion has shaped decades of fitness advice. When you eat before training, your body releases hormones in anticipation of incoming calories. That hormonal response can make you feel ready, alert, even strong. Your blood sugar rises, insulin is released, and your brain registers that food is coming. That sensation isn't coming from the food you just ate, though. It's coming from your body's expectation of that food. The energy you're using during that workout was stored in your body long before you stepped into the gym, possibly days before. And that raises a much more interesting question. If the fuel is already there, what really happens when you train without eating at all? And why do some people feel sharper, leaner, and more in control when they do? Why do they report feeling more focused rather than foggy, more energized rather than depleted? To understand why training without eating doesn't automatically drain you, you first have to understand how your body really produces energy. This isn't abstract theory. This is basic human physiology that somehow got buried under layers of marketing and oversimplified fitness culture. Your body stores fuel in two primary forms, and they work very differently. The first is glycogen. Glycogen is simply glucose stored in your liver and muscles, and it's your body's most convenient energy source. It's fast, efficient, and easy to access. Think of it as the cash in your wallet, readily available for immediate use. The average adult stores roughly 400 to 500 grams of glycogen, which equals about 1,600 to 2,000 calories of usable energy. Depending on your activity level, that supply can last anywhere from 12 to 24 hours. That's not a small reserve. That's enough energy to power multiple workouts without a single meal. The second fuel source is body fat, and this is where perspective matters more than anything else. Even a relatively lean person, someone at 12 to 15% body fat, carries tens of thousands of calories stored as fat. A person weighing 70 kilograms at 15% body fat has roughly 10 kilograms of fat tissue. That's approximately 90,000 calories of stored energy. That's not backup fuel, that's a massive energy reserve, more than enough to sustain life and activity for weeks. Here's the key point most people miss, the detail that changes everything. Your body will always choose the easiest fuel first. As long as glycogen is available, your metabolism keeps reaching for it instead of tapping into fat. Not because glycogen is bad or inferior, but because glycogen is convenient. It's accessible. It's already in a form your muscles can use immediately without much conversion. When food is constantly coming in, your body never has a reason to practice burning fat efficiently. There's no need. Why would your metabolism work harder to access fat stores when fresh glucose keeps arriving every few hours? Over time, that flexibility weakens, and that's when people start feeling dependent on eating before every workout. They feel sluggish without food, not because their bodies lack energy, but because their metabolisms have forgotten how to switch fuel sources smoothly. Even though the fuel they need is already there, stored and waiting, their bodies have become rigid in their energy pathways. This is where the story most people have been told quietly falls apart. The food you eat before a workout does not move straight into your muscles and suddenly become fuel. That's not how human digestion works, no matter how many pre-workout supplement ads suggest otherwise. When you eat a meal, it can sit in your stomach for 2 to 5 hours before it's even broken down enough to move into the small intestine. From there, nutrients are absorbed slowly over the next 4 to 12 hours, depending on the complexity of the meal and your digestive efficiency. In other words, the calories from your pre-workout meal are not available during that workout. They're being processed for later use, for tomorrow's training session or the day after. So why do people feel more energetic after eating? Because your brain anticipates fuel.
Hormones like insulin and dopamine shift in expectation of incoming calories, and that creates a psychological and physiological readiness. It feels real because it is real on a neurological level. But it's not the same as usable energy powering your muscles. The energy powering your workout comes from stored glycogen and body fat, not the meal you just ate. Once you see that distinction clearly, once you understand that the energy is already inside you, a different question emerges. If fresh food isn't required for energy in that moment, what changes when glycogen starts running low? What happens in that metabolic space between fed and starving? When you haven't eaten for 12 to 16 hours, your glycogen stores begin to thin out. They don't disappear completely, but they're no longer abundant. And when glycogen becomes scarce, your body doesn't panic. It doesn't shut down or conserve energy desperately. It adapts. It switches fuel sources. This is the moment fasted exercise changes the rules entirely. With less glucose available, your metabolism is forced to tap into fat for energy. Fat cells begin releasing fatty acids into the bloodstream, and your liver converts some of that fat into ketones, an alternative fuel your muscles and brain can use efficiently. This shift isn't extreme or unnatural. It's a normal biological response that humans relied on for survival long before constant access to food existed.
This ability to move smoothly between burning glucose and burning fat is known as metabolic flexibility. A healthy metabolism isn't locked into one fuel source. It adapts based on availability, switching gears without stress or disruption. But when you eat frequently throughout the day, especially refined carbohydrates that spike blood sugar repeatedly, your body rarely needs to practice that switch. Over time, it becomes less efficient at burning fat. Not because something is broken, but because it's never required. Your metabolism is like any skill. If you don't use it, you lose proficiency. Fasted exercise reintroduces that demand. It trains your body to access stored energy without stress or urgency. And once that switch starts working again, a cascade of internal changes follows that most people never experience when they always train fed. Once your body is no longer flooded with incoming glucose, a very different internal environment takes shape. Insulin levels drop, and that matters more than most people realize. Insulin is not a fat-burning hormone, it's a storage hormone. When insulin is elevated, fat is effectively locked inside fat cells. Your body interprets high insulin as a signal that food is abundant, so there's no need to release stored energy. When insulin is low, that lock comes off, fat becomes accessible. During fasted exercise, there's no fresh glucose entering the bloodstream, so insulin stays suppressed. That alone allows significantly more fat to be released and used for energy. Multiple studies have shown that aerobic exercise performed in a fasted state can increase fat oxidation by 20 to 30% compared to the same workout done after eating. That's not motivation or mindset, that's physiology. That's measurable metabolic difference. At the same time, another powerful hormone rises sharply: growth hormone. Growth hormone plays two critical roles in this context. It signals fat cells to release stored energy, and it helps protect muscle tissue from being broken down. Fasting on its own increases growth hormone. Exercise on its own increases growth hormone. When you combine the two, the effect is amplified significantly. In some studies, growth hormone levels increase several times above baseline during fasting and exercise conditions. This is one of the main reasons people are often surprised to find they don't lose muscle when training fasted. In fact, many maintain or even improve muscle tone while leaning out. Your body is prioritizing survival. Muscle is valuable tissue. It allows you to move, work, hunt, defend, and find food. When energy is scarce, your biology does not rush to destroy it. Instead, hormones shift to preserve muscle while pulling fuel from fat, which is exactly what fat is designed for. This is not a loophole, it's a built-in system. And when you understand that these processes are happening together, fat loss stops feeling like a fight against your body and starts feeling like cooperation with your own physiology. You're not forcing anything, you're simply creating the conditions where your body does what it was designed to do. As these hormonal shifts take place, another important change happens quietly in the background. Your insulin sensitivity improves. Insulin sensitivity simply describes how efficiently your cells respond to insulin. When sensitivity is high, your body needs very little insulin to move glucose into muscles, where it can be used or stored. When sensitivity is low, your body has to release more and more insulin to get the same result. Over time, that pattern contributes to energy crashes, increased fat storage, inflammation, and metabolic dysfunction.
Fasted exercise interrupts that cycle. When you train without eating, insulin is already low. Your muscles still need fuel, so they become more efficient at pulling glucose out of the bloodstream with minimal insulin involved. Your body learns to do more with less, and that improvement doesn't disappear when the workout ends. It can last for hours afterward, compounding over time. Mental clarity often improves as well, and this isn't placebo or wishful thinking. During fasting, your liver produces ketones from fat. Ketones cross the blood-brain barrier and provide a steady, efficient fuel source for the brain. Many people report feeling calmer, sharper, and more focused when they train fasted. There's less mental fog, less distraction. Fasting and exercise also increase a protein called brain-derived neurotrophic factor, or BDNF, which supports learning, memory, and brain resilience. Add in a rise in norepinephrine, a neurotransmitter linked to alertness and focus, and the mental shift starts to make sense. Your brain is responding to a state it recognizes as meaningful and adaptive, not dangerous.
There's an evolutionary reason all of this works so seamlessly. For most of human history, food wasn't guaranteed. Our ancestors didn't wake up, eat breakfasts, and then decide whether they had enough energy to move. They woke up hungry and had to move first in order to eat later. Hunting, gathering, traveling long distances, all of these happened in a fasted state. If the human body became weak, foggy, or fragile without food, our species wouldn't have survived. The opposite trait was selected for. Those who became more alert, more focused, and more capable when food was scarce were the ones who lived long enough to pass on their genes. Your body still carries that programming. It doesn't interpret short-term fasting as danger. It interprets it as a signal to mobilize resources, sharpen focus, and conserve what matters most. Fasted performance isn't a modern hack. It's an ancient feature built into your biology. Understanding that fasted exercise can work is one thing. Knowing how to apply it intelligently is what actually makes it sustainable. Not all movement places the same demand on your energy systems, and that distinction matters deeply when you haven't eaten. Low to moderate intensity aerobic exercise tends to work best in a fasted state. Activities like brisk walking, light jogging, easy cycling, or steady swimming rely heavily on fat for fuel. You can usually maintain these efforts for long periods without feeling depleted, even after many hours without food. This is where most people should start. It allows your body to adapt without stress and builds confidence rather than fear. You learn that your body is capable of more than you thought.
Higher intensity exercise is different. Sprinting, high-intensity interval training, jump rope at maximum effort, or anything that leaves you gasping for air depends much more on glycogen. When glycogen is already partially depleted from fasting, performance can feel compromised at first. You might not hit the same power output or sustain the same pace. That doesn't mean it's impossible. It means adaptation takes time. Some research shows that after several weeks of metabolic adaptation, people can maintain high-intensity performance even with lower glycogen availability. Their bodies become more efficient at using available fuel. But rushing into this too quickly is where problems start. Adaptation rewards patience, not aggression. Resistance training falls somewhere in between. You can lift weights while fasted, and many people do successfully. Growth hormone helps protect muscle during the session, and your body prioritizes maintaining strength. The key is what happens afterward. Muscles need protein to repair and rebuild. Training fasted and then delaying nutrition too long removes the raw materials your body needs to recover. You don't have to eat immediately, but you do need to eat within a reasonable window to support the adaptation you're trying to trigger.
Even though fasted exercise can be powerful, it isn't appropriate for everyone. Context matters enormously. If you're pregnant or breastfeeding, your body has elevated nutritional demands, and this is not the time to experiment with fasting protocols. If you have a history of eating disorders, fasted training can reinforce unhealthy patterns and should only be considered with professional guidance. People with type 1 diabetes or anyone using insulin need to be especially cautious because blood sugar regulation becomes far more complex without food. Chronic kidney disease, being significantly underweight, or taking medications that must be consumed with meals are also clear situations where fasted exercise may do more harm than good. Even if you're otherwise healthy, your body will tell you when something isn't right. Persistent dizziness, heart palpitations that don't settle after rest, confusion instead of clarity, extreme weakness, or nausea are signals to stop. These are not badges of discipline. They're warnings. A simple rule applies here. If symptoms don't improve within 10 to 15 minutes of resting and hydrating, end the session and eat something light. Fasted exercise should feel controlled, not punishing. It should enhance your training experience, not diminish it.
When you pull all of this together, one thing becomes clear. Exercising while fasted isn't reckless, it isn't extreme, and it isn't something reserved for elite athletes or biohackers. It's a tool. Like any tool, it works when it's used with understanding and restraint. Your body was never designed to need constant food in order to function. It was designed to adapt, to switch fuel sources, and to protect what matters most when resources are limited. Fasted exercise simply gives your metabolism a reason to remember how to do that. It reawakens a biological capacity that modern eating patterns have put to sleep. This doesn't mean everyone should train on an empty stomach. It means you now understand when it can help, when it can hurt, and how to approach it without sacrificing muscle, performance, or long-term health. The goal isn't suffering. The goal is control. Control over your energy, your metabolism, and the signals your body responds to every day. Control over how you feel, how you perform, and how efficiently your body uses the resources it already has. So here's the real question. Some coaches insist you should never exercise without eating. Others swear fasted training is the only way to do it right. After hearing the full picture, where do you stand? Is fasted exercise overrated, underrated, or simply misunderstood? Let me know in the comments. And if this helped you see your body differently, subscribe for more science-backed insights into how your body actually works.